So ladies and gentlemen, what we are going to do now is you got to learn the skills of how to calculate these formulae. But before we do that, you got to learn how to convert minutes to hours, because sometimes some of these things can be a little bit tricky for some people. So learn how to convert minutes to hours. A quick one, the easiest one. How many minutes make an hour? How many minutes make an hour? You can tell me. Just type it there. How many minutes make an hour? Easy one, 60. Get used to answering these things, okay? 60 minutes make an hour. Okay, what is 0.25 hours in minutes? What is 0.25 hours in minutes? If you use your brain and you don't have a specific command to doing it, it can confuse you. What is 0.25 hours in minutes? Now, have you heard of if more, less divide? If more, less divide. Okay, so you know that 60, let me just go back here. You know that 60 minutes is equal to 1 hour. And so what will be, you see, I'm putting how many minutes will be equal to 0.25 hours? That's the question. And now we know that it's going to be less, isn't it? It's going to be less. So if it is going to be less, then the more divide. The more divides here means the more must come down. So it's going to be, let's represent this one by x. So we are going to have, the more divide means that you should have x divided by the 60. 60 is more, so it must go down, which means that will be equal to the 0.25, the more divide, the 1. So the answer is going to be 60 times 0.25, and so our x is going to be 0.25. That is how this is going to be. But it's very cool. I know some of you got it. Okay, it's quite cool. It's simple. It's fine. And it's cool. Fine. That's fine. Okay. However, what is important is your ability to be able to fully understand it and go. So let's get another one. 10 minutes equal how many hours? Use the same principle. 10 minutes. 10 minutes equal how many hours? You can tell us. 10 minutes is how many hours? Okay. So the way you do, okay, let me just take you back to some of this. Okay. You got to know how to compute this. You got to know how to compute this. Okay. So I'm trying to help some of you here to be able to. 10 minutes equals how many? So again, you hear 10 minutes. Okay. Is equal to how many hours? X hours. You don't know that. Okay. But you know that 60 minutes is 1 hour. Okay. So 10 minutes will be what? Will be less. So again, if less, more divide. More divide. The word divide means denominator. Okay. So if less, so 10 minutes, more divide, the 60 will come down. And then you will have x over the 1. Okay. So when you cross multiply, you are going to have 60x equal to 10. And that means that x is going to be 1 over 6. And 1 over 6 is going to give you what? It's going to give you 0.16667. 0.166. So this is how you compute. If you remember the principle of if more, less divide, if less, more divide, that will help you in computing this. Okay, let's go to another one. Okay, let's go to another sort of questions related to this. 40 minutes is how many hours? This time, very easy. 40 minutes is how many hours? 40 minutes is how many hours? 40 minutes is how many hours? This one is very, very quick. Yes, you can tell us, Once I get a first answer, second answer, third answer, then I know that the rest are good to go. 40 minutes is how many hours? 0.66. Very good, done. Now, 0.6 hours is how many minutes? 0.6 hours is how many minutes? 0.6 hours is how many minutes? 36 minutes. Okay, so you got to master these. You come to appreciate why I want you to master it, because if you don't know these simple conversions, it makes it a little bit difficult for you to understand what you're about to do. All right, hope you're all fine. We are good to go now. Okay, so now let's do some of the calculations here. Okay, some of the calculations. Now, of course, because you are beginning, I told you to write all the formula. So I hope you were able to write all the formula. But if you happen not to have been able to write any, don't worry, let me know and I'll teach you. So, question: if it takes 5 minutes to serve a customer at Papaya, how many customers are served in an hour? Now remember, what are we computing? Are we computing the arrival rate or the service rate? Which one? Which one is this? Is it arrival rate or the service rate? It's a service rate. Very good. Very good, Eunice. It's a service rate. So on the basis of that, we are finding mu. So if it takes 5 minutes to serve a customer at Papaya, how many customers are served in an hour? So you must have done your conversion first. Yes, who can crack it? How many customers are served in an hour? Michael has given me an interesting answer. He's right. He's right. Stephen confirmed it. Now let's see how. So first thing you want to do to understand this thing is that first, how many minutes are there in an hour? 60 minutes. You all know that. Okay, we all know that. So 5 minutes is one customer. So if it takes 5 minutes to serve one customer, then, so in this case, you have to work everything in minutes. Okay. How many minutes are there in an hour? So you have 60 minutes. So it means that 60 minutes, you serve how many customers? Okay. So remember, 5 is one customer. So 60 will be X. Okay. Sometimes I always say that if you use if more or less dividers, okay. So 5 minutes will give you one customer. So 60 minutes will give you how many customers? And that is going to be 60 divided by 5. And that 60 divided by 5 is 12. So that means that it's going to take you 12, it's going to take you 60 minutes to serve 12 customers. So 12 customers are served every 60 minutes. It's a very simple start. Very simple start. If you don't get it, you raise your hand. So the service rate is 12 customers per hour, served per hour. Always remember it is per hour. So if you are writing it, you always don't have to just write 12. But it's good to write 12 per hour or per 60 minutes. Once you bring the per, it helps one to know the fact that we are dealing with, in this case, either a distribution of Poisson or negative exponential. Let's take another example. Okay, I've got a hand raise. So, but again, you can just say that 12 customers per 60 minutes. You can just say that. There's nothing wrong with that. 12 customers per 60 minutes. Okay, so let's take another example. And I like this one because the thing about this one is that it makes you think even further. A system has one service facility, just one. And this service facility can serve 10 customers per hour. So straight away, you got to note it down. 10 customers per hour. And of course, you can see 10 customers per every 60 minutes. Now, the customers arrive at an average rate of 6 per hour. The customers, they arrive at an average rate of 6 per hour. What are the chances that a customer has to wait? What are the chances that a customer has to wait. Now remember, if a customer has to wait, it means that the server is being what? Is serving. So it means that the server is busy, isn't it? The server is busy. That is why the customer has got to wait. So we are looking, and the word chances here deals with what word? What word is chances? What are the chances? What word is that? Exactly.
Probability.
That is probability. And so because that is probability, what it means is that we have to calculate the probability that a customer has to wait, which is the same as saying that the utilization factor. The utilization factor. And of course, if you can remember your formula for utilization factor, just take it back here. Do you remember the utilization factor? Lambda over mu. Okay. The utilization factor. That's what you are being asked to handle. So if you know the probability that I'm being utilized, so you gotta wait. That's a question that you are being asked. Now the question first of all said the system has one facility and it can serve 10 customers per hour. Okay. 10 customers per hour. So we are looking at 10 customers every 1 hour. So that is 10 customers every 60 minutes. That's what it means. So you have 10 customers every 60 minutes. The customers arrive at an average rate of 6 per hour. Now, remember, it said that the system has one service facility. And that one service facility is 10 customers per hour. So that 10 customers per hour is the same as what? The service rate. So 10 customers are being served every hour. So mu is equal to 10 customers per 60 minutes or per every hour. Now lambda, we'll take you back to the question. Because sometimes when you look at a question, it helps you to think. Okay, the customers arrive at an average rate of 6 per hour. So that should tell you that the lambda is what? Is 6. Now remember, that one is also in an hour, so it's like the same 60 minutes. Okay. So you have 6 customers per hour. Now, what are the chances that a customer has to wait? And this is the formula you have there. So mu is going to be the lambda 6 over the mu, the service rate 10. What are the chances that a customer has to wait? And you have your answer right there, 0.6. 0.6. So once you got that value, that is the 60% chance that a customer has to wait. So there's a 60% chance that customer has got to wait because of what is happening, because the server is very busy, very tight. Okay, that is how you compute it. So let me just show you how it was executed. So this is it. All right, let's look at another one. And this is a kind of an exam question that we looked at some time. The ticket booth on a Brauho campus is operated by one person who is selling tickets for the annual Yam Festival. The ticket seller can serve an average of 15 customers per hour. Now listen carefully. Can serve 15 customers every 60 minutes. On average, 3 customers arrive to buy tickets every 15 minutes. So some of them are in hours, some of them are in minutes. Question. Determine the average time a ticket buyer must wait in the queue. Determine the average time a ticket buyer must wait in the queue. Can you pause and then work it out and let me see? Determine the average time a ticket buyer must wait. What is this question really asking you? This question is asking you really to calculate what? What are you technically speaking calculating? Yeah, you can either raise your hand or type me your answer. What are you technically speaking calculating here? Determine the average time a ticket buyer. Which of our symbols? Remember, we had symbols such as PO, PN, L, LQ, W, WQ, and then we had U, and then I. You remember all this. So which one are we calculating? Which one? So look at the word, determine the average time. When we were talking, I told you that some of them, these ones, they deal with what? They deal with the probabilities. These deal with the number of customers. These W deals with the times. And now we are telling you the time the ticket buyer must wait. And I told you that anytime you have the wait, it means you are queuing. And because you are queuing, it means that we are dealing with the queue. But the question is, are we dealing with the number of customers L, or we are dealing with the waiting time W? But as you can see, we are dealing with the waiting time W. So let's go back to the question and then make sense of the information that we have. So the information is that the ticket seller can serve an average of 15 customers per hour. So you have to convert everything to minutes. Okay. So if you are serving 15 customers per hour, then, and then of course, this guy is receiving 3 customers arriving to buy tickets every 15 minutes. So 15 customers are being served an hour. Now there are 2 possibilities. You can convert everything to an hour or convert everything to minutes. My advice is to convert everything to minutes or convert everything to an hour, depending on which one you like. Okay. So let's try and do that. So you have 15 customers per hour. 15 customers per 1 hour or 60 minutes. And then 3 customers are served. Okay. Oh, sorry, 3 customers arrive every 50 minutes. 15 customers are served. So serve here means this one is referring to the MU, the service rate. And 3 customers arrive every 15 minutes. Okay. That is a lambda, but we need to convert it to the 60. So if you have 15 customers arriving every hour, okay, let me just delete this one and make it hour. Every 1 hour, okay, then it means that how many are arriving, or if you can use this 1 hour here. Oops. If you have 3 customers arriving every 15 minutes, how many are arriving every 60 minutes? How many are arriving every 60 minutes? How many? First of all, you should know that the service rate is guaranteed. So mu is guaranteed to be what? 15. 15. Now what we need is a lambda. So how many are arriving? You have 3 customers every 15 minutes. So you have 12 customers every 60 minutes or every 1 hour. You know that. Okay. Minutes or every 1 hour. 12 customers. You should know this by now. Okay, so you have 12 customers. So it means that the lambda is going to be 12 customers per hour. That's how it's going to be. Now that you know your lambda, you see, it's not all the time you wouldn't know your lambda or your mu. Now you know your service rate is 15, and you know that your lambda or the arrival rate is 12. And the question was very clear. The question said that how determine the average time. Let me take you back to the question. The question says, determine the average time a ticket buyer must wait. The average time a ticket buyer must wait in order to be able to deal with the queue, must wait in the queue. Now, of course, if you can remember, we just go back to our formula here, waiting, WQ. That's what you're being asked to do. This is the WQ. The WQ is lambda over the mu into bracket the mu minus the lambda. Now remember the mu is 15. So if you are calculating this, okay, this is going to be lambda, which was 12, divided by 15, which is the service rate, minus the 15 into bracket 15 minus the 12. So this is it. And then you just take your calculator and punch. Okay, 15 times 3 is 45. 12 by 45 will give you the waiting time. But you see, the waiting time will be in hours. And you can later convert it into minutes. Okay. So when you do this, what are you going to get? Let's check. When you do this, I'm just going to just show you the answers because I know you know what we are doing. Okay. So you're going to get an average answer of 0.2667 hours. That's what you're going to get. And when you multiply that by 60, that will give you 16 minutes. 16 minutes. So this is the average time a customer has to wait in the queue because the server is busy and the person has got to wait. 16 minutes waiting time. Now, let's look at the next part of the question. Next part of the question. It says that determine the portion of time the seller is idle. Determine, the word portion is percentage. Determine the portion of time the seller is idle. So tell us the portion the seller is idle. Now watch carefully if you can remember the portion of the idle time. Okay, this is it. The idle time is I, which is 1 minus the utilization factor. So what is the portion of time the server is actually busy? Well, it's just 1 minus the lambda, which is the 12, over the mu, which is the 15. And that gave us 0.2667. So 1 minus that will give us the right answer. Okay. So when you do that very nicely, you are going to get a very beautiful answer, just like what we have here, 20%. 20%. You're going to get 1 minus 12 over 15, which is 0.2, multiplied by 100, 20%. Next one. It says that the management, and this is a little bit tricky, the management of the campus likes to have its operators working 80% of the time. So the operators are always working 80% of the time. Now, if they are working 80% of the time, what it means is that they are being utilized, the utilization of them is 80%. So U is 80%. Don't forget that. So U in this formula, the U in this formula has been given. Okay. If you go to the actual formula that we know of, okay, the U has been given. What is that? This is it. So your U has been given to you. And now that a U has been given, you are being asked a certain question. You are being asked to do something. So remember that U has been given. Now, if U has been given, I can ask you to find the lambda, the arrival rate, or the mu, which is the service rate. I can ask you to find it. It's just cross multiply, and you will find one of them. If one of them is given, you can find the other. So let's look at the question we are being asked, and you will know whether it's a lambda you are being asked now to do, find, or the mu, which one you are being asked to find. So what does it say? Well, it says very clearly here that the management likes to have its operators working 80% of the time. What must the service rate be? Ouch. Now you know which one is being asked to find. Is it a lambda or the mu? Which one are you being asked to find? Is it a lambda or the mu? Can you type with the answer or raise your hand? Anyone? Which one are you being asked to find? Is it a lambda here or the mu? Mu is mu. Lambda, that one is Lambda, is a mu. So now that you have your 80%, what is your mu? It says, what must the service rates be in order for the operators to be as idle as management would like? Now that's quite tricky, but it's the same thing. If what must the service rate be in order for the operators to be as idle as management would like? It's the same as what must the service rate be in order for the operators to be working, to be busy as management would like to be. Because if you are idle, you are either idle or busy. So he just wants you to find the service rate. Now, if they have been working 80% of the time, it means that the utilization factor here is 0.8 equals to lambda over mu. Okay, what must the service rate be? The mu. So it means that you're going to use the original lambda of 12 divided by the mu. You cross multiply, you do mu is equal to 12 over the 0.8. And this is what the service rate is going to be. And you will get the same thing. So the service rate will have to be 12 over 0.6. That is how the service rate must be for the operators to be as idle. Of course, if they are idle, it means that the opposite of that is, they are busy. So 1 minus that. So you can use any one of them. You can use the idle formula to get it. So it has to be 15 customers per hour. And this is exactly how you compute some of those things. Very good. Any question on this? Any question on these technicalities before we go to the next situation?